and welcome to the SUDO Show, where Linux meets business. On today's episode, we're going to talk about the ABCs of CVEs. And if you don't know what CVEs are, don't worry, we'll get into that very shortly. But Neal, how are you? Brandon, it's been a minute. I'm so glad to have you back in the studio. How are you both doing?
This is fantastic. It's been wonderful. Actually, no, it's been kind of a rough couple of months, but I have cool, exciting stuff anyway. Like I was at Linux Fest Northwest and was at Scale before that, and I was at FOSDEM and CentOS Connect even before that. But you know what the absolute coolest bit is? The coolest bit is this bugger. It is awesome.
It's a laptop. Okay.
It's a laptop. It is not only a laptop, it is an awesome laptop from the people at Le Framework.
Is that the new Framework Pro?
It is the new Framework 13 Pro.
Okay,
I've been daily.
Cool,
When I was up at Linux Fest Northwest a couple weeks back, I was basically daily driving it, trying it out, working through it. Can't really share too many specifics about it, but I can say, man, this is an amazing laptop to travel with and to use. I'm jealous of this thing. Like my normal daily driver computers for travel are not as good as this one. This is a phenomenal machine, and it runs Fedora Linux beautifully.
You're not running Ubuntu on it?
No. I know it's Ubuntu certified, but it'll also be Fedora ready.
Have you put Windows on it?
What the?
I mean, if you're going to test the laptop out thoroughly, I am just wondering if any of your testing process includes Windows or FreeBSD, or maybe you have Solaris Open Indiana on there.
Oh man, do you
OS
really
3
want me
Warp
to be?
5.
Jeez, are you just rattling through?
Yeah, I'm just rattling stuff off.
Warp 5 doesn't even exist, first of all.
You know, Neal, I wasn't going to do this to you, but I think I'm going to anyway. So your impossible challenge for the month of May is to install as many operating systems on one drive as possible with all the multi-boot working.
Oh my god. That is actually an impossible challenge. It's actually been a really long time since I've done multi-boot on a computer. Like, I haven't done that since I was first doing Linux stuff way back in the aughts. So
yeah,
it's been a very long time.
Well, one of my systems used to be triple boot.
Yeah, actually, I was
Windows 98, Windows 2000, and Red Hat Linux 6 or 7.
Say 6.0 or 6.1 would be
it
appropriate.
Might have been 8. Actually, it was 8. It was 8.
Oh,
no, I think for me it was Windows 98 Second Edition, Windows NT 4.0 Workstation, which, by the way, is super hard to actually get to be in a multi-boot properly, but I did do it. And Red Hat Linux 7.3, I think, was the one I was using with it. And mostly I was able to get the multi-boot working by tricking the crap out of the two Windows copies with Lilo. And back then, Red Hat was really into like actually skinning stuff, and like Lilo had art that made it look like the box, like that box.
I remember that.
And the saddest day is when you got LI and nothing else.
Oh yes, then you knew your computer was born.
Yeah, that's a bad day. But Brandon, it's been quite some time since we've had a chance to talk to you. What's going on with you these days?
Well, not too much right now. It's been a crazy few months. A lot, snake breakneck speed, going with innovation everywhere. That's trying to keep up with that. And as of this recording, next week's Red Hat Summit. So really looking forward to that. Lots of really cool things going on there. So I'll be hanging around Atlanta. So hopefully I'll be able to see Neal there. And
yes, I will be there too. And I'll be in Atlanta. Actually, it's been quite a while since I've been in Atlanta other than to transit through the airport. So it's going to be, I think the last time I seriously hung out in Atlanta, I went to Dragon Con, which was all the way back in the year I graduated college. That is how long ago it was. So I'm
The last
sure.
year.
Oh man, you wish. I wish I was that young still. Full of energy and vive, joie la vive, and whatever. Like, nope.
Well, I think instead now your life consists of, as of this recording in the past couple of weeks, dealing with some nasty little security vulnerabilities that have come out thanks to AI and the constant stream in which for every one bug that is squashed, for every one exploit that's patched, another 10 are discovered until we find out that our brains ourselves are now going to become the CVEs. So, kind of curious what CVE stuff you've had to deal with, because before we started recording this episode, you were spiritually storming around the studio, waving your fist in the air at all the things that you had to deal with. So please let the audience know what you've had on your plate, because this is pretty interesting.
The last couple of weeks have been a litany of vulnerability reports that I've been getting. And actually, I have more coming from this through AI things that I, again, embargoed, can't discuss, all that other stuff. That's how responsible disclosure works. But like, for example, like the week that we were working through the Fedora 44 final release in Final Freeze, just like literally days before we were going to decide whether it was going to be released or not, PackageKit had a vulnerability fix published and all that stuff, and I had to go and backport it and ship it to all the Fedora branches. That was the pack to the root from the interesting people at Deutsche Telekom, who have a security team that leveraged AI to fuzz and inspect basically the software that ships in Fedora Workstation. Apparently, I guess they use Fedora Workstation inside of DT, and they used that to they used AI assisted stuff with Claude Opus, and they discovered an exploitable vulnerability. They did the responsible disclosure thing of talking to us, giving us a confidential report, and working through evaluating the patch to fix it, then preparing and testing the fix, making sure that the proof of concept they gave us, which was not disclosed, to verify that it was in fact fixed. Then we went through and released it, got a CV assigned to it, reported it accordingly to all the peoples, the different distributions and whatever. Everybody was kept in the loop. We did that through the process that Linux distributions already have to be coordinated for disclosure. There's a mailing list from OpenWall, which is an organization that has a lot of these security things, called the Linux distros list. And we went through that process, and I mean, it basically worked out fine. Like that was the nice case that we had, and that was a few weeks back. And the not so nice case that happened was copy.fail, which was earlier this week, I think. This was done a little bit on the weird side. So the people that discovered this, I think they also used, it was like the Exint code people. They have their whole shtick is AI research for security vulnerabilities and audits and stuff like that. Um, there's a lot more details. There's a website for it, copy.fail. Again, we'll put links for the different things that we're talking about into the show notes. Where they found a trivial flaw caused by an optimization that was coded wrong. And it affects every Linux distribution, I think going back to Linux kernel 4.14 or something like that. It's like, it's quite old. It goes pretty far back.
Tell me more simple, help me understand how an optimization creates this sort of thing, because I certainly have no background in kernel management, kernel development. I'm the guy that probably when he sees the CVEs come in has a rule in his inbox that says move these to the trash. So
Well, I hope that's not what you're doing,
No,
man.
I don't actually do that. Just so you know, I just want to see if you're paying attention.
Yeah, well, I'm definitely paying attention.
Yeah,
Um,
but
so,
help us understand a little bit more about that at kind of a more fundamental level.
so there's a very detailed write up. So I'm not going to so people can go and read that to understand the nitty gritty. But like the high level was that basically like sometime in I think it was like 2016 ish or something like that. There was an optimization that was made to like how we do some page handling for cryptographic stuff. And it takes advantage of the fact that the copy on write works the way it does by like keeping most of the data in the original place and only writing the deltas into the new place and creating references across them. And so this is a different version, and the thing is like it basically goes through the same similar paths through VFS and does or which is a virtual file system. So like the layer in which your stuff talks to the kernel's storage layer, that's called the virtual file system. And it virtual refers to the fact that this is an abstraction layer, it's not the actual data. You will hear the use of virtual in a lot of contexts in the Linux kernel, and they don't mean the same thing you think they are. Virtual in this context means abstraction. It means like you are papering over details that don't matter. And in this case, a trivial 732 byte Python script basically can get you root on any computer, which is pretty bloody bad. So they went through the Linux kernel process, which is you report it to them, and then they go and do the thing where they check on how to evaluate it, how to verify it, they make a fix. But the Linux kernel process is different from all the other places. Most products and projects go through coordinated disclosure. And that is a process in which we hold back until we get relevant known stakeholders prepared for this so that when the fix is being published, everyone has it at the same time to shrink that window of weakness to as small as possible. But the problem is that the Linux kernel doesn't follow that method. What they do is, as soon as they've resolved a fix and they have merged it and it has been released, they will then disclose the vulnerability after the fact with the full report. The only time they don't do that is that there's already multiple stakeholders involved, essentially requesting privately before it gets disclosed that they not do that. Since the responsible disclosure process that involves the Linux distributions and other stakeholders was not invoked simultaneously, what happened instead is as soon as the Linux kernel was good, it got shipped, it got described, and the report was published. And every Linux distribution was now fair game. Every operating system, every deployment was fair game. That was what happened. And so as a result, all of us people working in Linux distributions essentially had to bum rush a backport of the fix to everywhere. And like I know Red Hat had to do it, SUSE was doing it, Fedora was doing it. Like it was all over the place. That was copy fail. That is an example of inadvertent, like unintended consequences causing major pain for a lot of people. The last one was actually just brand new, like it was just happening like today, as of this recording, May 7th, is Dirty Frag, which was actually disclosed, coordinated, and all that other stuff. Like it was done properly. It went through the upstream process. It also went to the Linux distros. It was actually held back. But what happened was that the embargo got broken early, and the proof of concept exploit got published several hours earlier, which essentially forced all of us to go in and deal with it now.
Explain the whole embargo process a bit, because I'm not even familiar with it.
So embargo is the word that we use to describe. We have the thing, we have all the stuff, we have the details, we have the fix, we have the remediation. We are intentionally holding it back while we get everyone who we know is affected to be aware so that they're all prepared to ship at the same time. So you'll often hear the phrase coordinated disclosure or coordinated release. This is the formal term that we use. Embargo is the term we use when it hasn't been released yet, when it hasn't been disclosed yet. So you'll hear someone, if you're ever involved in a situation like this, say, yeah, this is under embargo. It's very similar to like, hey, this is basically under confidentiality agreements or something like that. Like in the businessy sense, it's confidentiality. In the security world, we say it's under embargo. And that sort of meant we couldn't discuss any of this. But then the embargo got busted because someone basically published an exploit for it, a proof of concept exploit several hours earlier than planned. And so when that happens, the embargo is essentially lifted, and disclosure happens immediately. Because like there is no point if now people can attack you. So that's what made today particularly stressful, because like right before coming to this call to do this recording, I was making kernel builds for Fedora Sahi Remix and CentOS Hyperscale to address Dirty Frag. It's out the door now, and I have to deal with it.
Okay,
This is basically what my day has been, and actually the last several days have been.
So what you've painted here is a picture of from discovery until basically reporting and to some degree patching and management. And that's kind of at the distribution level. Now, Brandon, you deal with a lot of different types of end users across different markets. I know there's some specifics, obviously, you can't get into, but in terms of kind of keeping people's heads screwed on straight when a CVE comes out versus just, running away from the building, everything's on fire. What have you found are some of the best practices for handling patching or testing and releasing patches before they go out into what we'll say a production world at a customer site?
I even have some customers, their hair will be on fire for any CVE. But so generally, just keeping a level-headed announcement about it with the facts is really the best. It's really the only approach. I don't like a lot of the fear-mongering that always comes out with these, because a lot of these, even some of this, high severity ones, I don't want to downplay high severity CVEs. I'm not trying to, but some of them are they are not exploitable in the environments that most systems are in. So just remembering that disconnected systems, especially disconnected systems from the internet, generally are going to be fine, but it's still important to patch, because if someone loads up a code that can be exploited, that system can be manipulated. So even if it's behind the firewalls, so because that's generally one of the that's the issue we always have to think about, is just keep a level head about it. It's not these systems are, they're important. Like, having to do all this stuff is important, but we gotta keep a level head about ourselves. It's just remember that these things happen all the time. Yes, there's some that are more important than others that have active exploits, but we just keeping a level head is the most important part, and getting them out as quickly as possible is just using your standard patching mechanisms are usually fine. Your patch Tuesdays usually just fine to patch most of these stuff, or just patch it over the as it comes in. A lot of my customers have patch schedules. And guess what? They're going to get fixed no matter what. So running around with your hair on fire is not going to solve anything. Just keep a level head about it. Just read the CVE, understand your risk. I think that's the most important part, is understanding your risk. That's all that matters at the end of the day, is understanding your risk.
Yeah, I mean, it's important to understand that, like, these CVEs are the CVSS scores, which is the vulnerability rating, which is based on the conditions of how they're accessed, how easy they are to take advantage of, and how much access does it give you. Like, so these scores are based on the conditions in which they are evaluated under. So if someone is evaluating this on, let's say, an Ubuntu system, and they classify this as a Linux CVE, that score can actually not apply the same way for, say, a Fedora system or a Red Hat Enterprise Linux system or an Alma Linux system. Like, because what winds up happening is that the conditions in which the system operates in also influence how this works. Like, so a good example of this is, I think, one of these vulnerabilities, I forget which one of them, I think it is copy.fail. That's the one with the ALG, with the network ALG thing. Copy.fail doesn't actually work on Android systems because SE Android, so their implementation of SE Linux, blocks access to AFALG. So that particular network transport mechanism, which is required to access the exploit, just straight up doesn't work. To access the vulnerability, sorry. To exploit it, you need AFALG support. The SE Linux policy that is shipped on all Android phones just doesn't allow this. Now, SE Linux policies and AppArmor profiles that exist on contemporary Linux systems don't necessarily have a blocker for this. They may sometimes restrict it, but in most cases, they don't. What is probably going to change going forward is that this is going to be reevaluated. Now, to be clear, in this particular case, it was the condition in which this matters is that the kernel modules or the kernel code related to AFALG support was in your kernel and enabled and active and being used. My current understanding of it is that the conditions in which that is true is so small that despite the high exploitability, it probably doesn't matter for a lot of systems. Like, because for example, RHEL doesn't ship IWD, which is an alternative wireless networking management tool. That is not in RHEL, so therefore AFALG would not be activated automatically. On desktops, you might have it activated because Bluetooth uses it, but also those systems are often not just straight up wired in a way where you can poke into it from the internet. So this is where you got to understand and contextualize your risk. These vulnerabilities are bad sometimes, but they are also not hair-raising most of the time. The PackageKit one was probably quite bad, which is why, like, because it affects everybody in all configurations and was trivial to exploit, which is why we didn't disclose the exploit code. And we made sure it got fixed basically day of disclosure across all the major distributions. But it is actually somewhat rare for a vulnerability to exist in an unconditionally, oh my gosh, this is horrible case. Like, and even the PackageKit one isn't, oh my gosh, this is horrible. It could also be restricted by, hey, if the user just doesn't have access to PackageKit in the first place, it probably can't do anything. And that's, again, there are mitigation strategies, there's risk profiles to understand. You start from that, and then you can figure out how you want to go about it and what you need to do to remediate. And maybe it is, oh, hey, this doesn't matter that much in my environment because the conditions make it so that this is too difficult to take advantage of. I will just wait for my patch Tuesday or patch Saturday or midnight o'clock that I use to apply and do reboots. Like, I mean, whatever you call it, right? There are, sometimes it does require something extraordinary. And some Linux distributions offer ways for you to handle extraordinary vulnerabilities. Like, so for example, Dirty Frag and copy.fail. Like, if you were actually being exploited right now and you do not have time to make a window to fix it, if you are using a system like Red Hat Enterprise Linux or SUSE Linux Enterprise or any of the number other, like, or any distribution that's like, Tux Care supports with their kernel care thing, or any of the number of vendors that do stuff like this, you have live kernel patching for these things to mitigate you until you can get to your reboot window. Now, I will make it clear, live kernel patches are not a permanent fix. They are a band-aid mitigation that are supposed to be used to tide you over until you can apply a full update to fix everything. But depending on what you're using, what your environment is, and what your risk profile is, you have all these tools available to you. So the most important thing is don't bloody panic.
I think that's a great piece of advice to give to, let's say, a new cybersecurity graduate who's just getting into the field and finds out that they're just getting bombarded constantly with news and news and news of CVEs or this exploit or this hack or this place got breached. If I'm a new cybersecurity graduate and I'm going into a business of, let's say, 100 people, and I'm told, hey, tighten things up here, and we'll say most of the infrastructure is Linux, what tools are available to me to kind of discover what I have, to know what to be able to patch against? Because if I don't know what I have and what's relevant, I can't filter out which CVEs matter and which don't.
They're running Red Hat Enterprise Linux. They can use Red Hat Lightspeed, formerly known as Red Hat Insights, and figure out that what their current state status. And so, what any vulnerabilities, any bad configurations, like that is a wonderful tool for that. And, thankfully with things like Ansible, Salt, Puppet, you can quickly remediate most of those suggestions from Lightspeed. And today with tools coming out every day, yes, they're AI based. I don't really care. The genie's out of the bottle. I use AI every day.
I think we did an episode about AI.
Yeah.
Yeah, we might have done a couple.
Yeah. The genie's out of the bottle. It's not going back in. I use AI all the time, and you can use AI today to help manage and configure your Linux. I think you can even do it with Windows, your Windows estate. That is, if I'm a security engineer or system administrator, today I'm using AI to help manage this. Yes, I will verify. Of course, I'm going to verify, but AI is at managing this stuff at scale, being able to look at your configurations and ensuring that they're properly, all your Apache configurations, your Nginx configurations, things that actually prevent breaches into your systems are good. Then utilize AI as much as possible. That is my advice to everyone coming into this field now. And if you're not, I don't say that. I haven't really said this because, like, when we recorded our AI episode, AI was still pretty much like, yes, it's here. Start using it. I actually am going to say this: anyone not using AI today needs to start. And Linux distributions that are not utilizing AI to help build their packages, to help build secure configurations, I'm going to say this right now: they need to start doing it now, or they're not going to be around.
So I'm gonna be going to be a little counter to Brandon, and I'm going to give some classical advice. So while it's true that AI tooling has significantly improved, even in like the past 6 months and the past year, or whatever, you don't necessarily need AI for your remediation strategies, right? If you're trying to do your basic principles of understand, assess, and attack, counterattack, right? You think about what your environment is like. Make sure you have tools in place for you to understand your environment. So, a good couple of examples, just open source projects that I can heartily recommend for this is um, the Foreman, which is the upstream open source project that is the basis of the product Red Hat Satellite. Another example, another great project is the Uyuni project from the folks at SUSE. That is the upstream project, freely available with an appliance and everything for the SUSE
Sorry,
multi-Linux
sorry,
manager.
sorry. I had to interject. That used to be Red Hat Satellite too.
It also used to be Red Hat Satellite, but today,
Its former name was Spacewalk.
yes. And I love Spacewalk. I used to be a contributor to Spacewalk. It's a great project. But Uyuni is the upstream to SUSE's multi-Linux manager. Both projects support managing a wide range of Linux distributions. When you pair this up with Linux distributions that provide machine-readable data, security data that you can use for your inventory management and lifecycling, this can be very powerful for you at a glance to understand the scale, scope of vulnerabilities that may affect you, and you can understand your overall risk profile. Linux distributions that include this information are like obviously Red Hat Enterprise Linux and SUSE Linux Enterprise. As enterprise Linux platforms, they actually offer this built in as part of their package management stack. This is just part and parcel of how things are done. In community enterprise Linux places, you'll have Alma Linux and other relatives, as I like to call it, as well as OpenSUSE Leap. Right, these are two platforms in that realm. And then you go further on into the even more community centric Linux platforms that are not necessarily enterprisey. You have distributions like Fedora that, as part of shipping updates and whatever, they do actually provide some level of this data as part of their update release process. You can use this information to within your inventory management that is included in these tools. So in the Foreman, you have your machines registered, you have Catello, and these things all working to connect up your mass management tooling, whether that's Ansible, Puppet, Chef, Salt, whatever, and you have your inventory and your repository content coming in, tracked in through the Pulp component. That gives you this holistic view that you can then use to understand, is there any kind of urgency that you need to actually handle? And then you can intuit based on rules, you can intuit based on business decisions, whatever you want to do there. And again, this equally applies when you're using Uyuni or SUSE Multi-Linux Manager. Now, again, the Red Hat product is Red Hat Satellite. The SUSE product is SUSE Multi-Linux Manager. I think officially Red Hat only supports Red Hat Enterprise Linux with Satellite, though
That's not
you
true.
could do whatever, right? It's still the same software.
It supports
SUSE,
more than RHEL.
yeah,
It supports more than RHEL.
yes. But again, I don't know for certain about all those things. I just know that it is technically possible because I've done it before. And SUSE Multi-Linux Manager, as it is implied in the name, supports all the different Linux distributions. They provide you commercial support for these sorts of things. So, like, if you are an agnostic and a multiple distribution shop, I think SUSE Multi-Linux Manager is probably a really good place to go. If you're really, really majority Red Hat shop, Red Hat Satellite is fantastic. And of course, as Brandon said, there are the Red Hat Lightspeed and the Cloud Insights and all these other things that are available to you with RHEL shops that give you many or nearly all of this functionality without the additional footprint on premises. But again, I'm giving you the conventional classical advice. Rolling out stuff like Foreman/Satellite or Uyuni/Multi-Linux Manager and connecting up all your footprint gives you the intelligence you need to be able to effectively manage your footprint at scale in a reasonable time frame. And that may mean don't do anything, because it turns out it doesn't matter, right? But you don't know until you have the information to do those things.
All right. So, Neal, you've given us some classical advice. Brandon, you've given us some modern advice. One of the concerns I have involving AI, or even some of the tools that you're using or you've brought up, Neal, are the modern day supply chain attacks. Now, this is something that I hear frequently about with software vendors that I interface with. And I'm always now concerned, is the tool that I'm using that's supposed to be a security tool now compromised? And obviously the big one that hit the enterprise space was SolarWinds. And I think that left a scar in everybody. So with the tools that you've mentioned, and even Brandon, some of the AI tools that you've mentioned, is there a way that you can safely ever trust whichever tool you're using, whether it's a classical tool or an AI tool? And if you're going to trust but verify, the old IBM adage, how would you verify, let's say, one AI against the other or one tool against another? I feel like now you're going to end up going down some sort of spiral that.
Yeah. You could do like a quorum of LLMs to determine if it's right. People have done that. I think it's insane. I think that's a waste of tokens.
It's also expensive.
I think it's
a brutally expensive.
It's a
brutally
waste of tokens.
Approach.
Yeah, it's a waste of tokens. So, supply chain attacks. Yeah, SolarWinds. Yeah, as soon as you said supply chain, SolarWinds was the first thing that came to my mind. That was a freak accident. Like, in SolarWinds' defense, that was a freak accident. Now, in an open source world, it is very important to verify where you get your software. There have been repos that have been hacked and had bad code injected into packages in different distributions. There have been, I think, vulnerable ISOs uploaded, replaced, and just verifying that the MD5 sums or SHA sums are the same. That's probably the most important. That's published. Like that's classic. That's definitely the classical way of doing it. Today, I think the thing that you have to worry about the most, because AI is everywhere. Like I already said, the genie's out of the bottle, is prompt injection. So now you need to watch out for that. That's not a supply chain attack. This is a new attack vector.
It's a new social engineering attack, right?
Yeah, exactly that.
Yeah. Like, I mean, the AI agents thing is actually the most of the things when it comes to being prepared or whatever are fairly straightforward to deal with. When it comes to the supply chain stuff, vet your supply chain, vet your inputs, right? Like, this is something that in the open source world, I don't know, I feel like sometimes we forget and sometimes we remember this. Like, part of the modus operandi of Linux distributions is trust and verify, right? We take sources from upstream projects, we prepare them and ship them. And as part of that process, there's a glimmer of understanding and introspection to understand whether what we're shipping is sane.
Mm-hmm.
I mean, it doesn't always work out. People are people, and it can go any way it can. But the XZ thing from, what was it, 2 years ago, right? That was discovered by a dude testing out an unreleased package that was in Debian's proposed for a thing, because he was a PostgreSQL developer who was testing a specific case and noticed it was just slightly too slow. And like, the Linus's law thing does really kick in as you distribute out the availability and access and the ability to test. So from that point of view, right, like, I think like Red Hat's doing some kind of trusted supply chain thing stuff with, and SUSE's doing something similar. I actually expect that this is going to be a more common theme that we're going to see, especially because we've had supply chain attacks on cargo, uh,
Yeah.
and we've had supply chain attacks on NPM. Oh my gosh, NPM's
NPM.
littered with them. And we've had supply chain attacks on PyPI, and that's the thing, right? With
Docker Hub.
CrateSite, Docker
Yep.
Hub for sure. I mean, Docker Hub. I think Docker put out a report that I don't know, it's like what, a third, 2/3 of container images are effectively unmaintained and highly vulnerable. Like that's pretty bad, and that wasn't a recent report, but nothing has actually changed since then, right? So sanitize your inputs. If you're using containers, don't use other people's containers. Make your own. Produce them. Have a process within your environment that you can then build and publish and consume and lifecycle your software. Whether that's with packages or images or appliances or whatever, because as long as you understand your process for software delivery, no matter which mechanism you're using, then you can fix anything that goes wrong. As soon as you treat it like a black box, you're ruined. That's really where it comes down to.
I agree to an extent. I think using a solid base image, whether that's a Fedora, UBI, from Red Hat, Alpine, whatever you pick the flavor of the week of base container image. But there are definitely, pieces of software where the convenience outweighs, is in the open source land. But if it's internal enterprise software, use a good base image. If it's Node.js, use the I
Do the best that you can.
I would use the UBI image and
Yeah.
go from there.
I mean, to be clear, right? You just have to understand how far you want to go to do this. Like, you can go at the application layer, you could go at the middleware layer, you could go at the base layer, right? It entirely depends on how far you're able to go, how far you're willing to go, and how far you want to go, right? Like, because willing, able, and want are all different dimensions of this, and you have to pick where you want to be. Like in my case, when I was working in a corporate environment, we went all the way down to the base image layer because we had tooling in our infrastructure that made maintaining base images actually super easy, and keeping them up to date was essentially fully automated because we controlled all of our inputs. We scanned and introspected it. We knew what content was coming in. All the open source software was either validated and verified, or we built it ourselves, or both. And the line of business software, that's not just internal software, but also any software you've purchased from a vendor. We did not automatically trust the method of delivery that the supplier gave us. We produced a method of delivery for ourselves, and we understood what we were deploying. But we were skilled. We had the infrastructure to do it, and we had the desire to make sure we continuously understood our footprint. Not everyone has the skills to do all of those things, and that's where you could lean on vendors like Red Hat and SUSE, and I think, and also like ChainGuard and these other companies who specialize, or Adara. They're a new startup that's like working in the Kubernetes space about security and that sort of thing. These companies, like, they exist to help you be successful when you know you can't on your own. Take advantage of them. Go work with them. That's what they're for. They are happy to do it. And yes, it may cost a little bit more money, but what you will wind up having is compliance, confidence, and you'll have a nice environment to work in. And like, that's, at the end of the day, that's what anybody only cares about.
Now, one of the popular words of the year or past year or two, especially when I'm doing things like cyber insurance forms for customers that I deal with, is immutability. And I always find out from the customer, I ask the customer, what do you think immutability means to you? And what I find is I get wildly different answers everything from, well, that's better than virus protection, or it's the end all be all, or it just means that certain files can't be altered. What the point I'm trying to make here is that a lot of these more nuanced and new terms haven't really been clearly defined. So in terms of our discussion today, does immutability through a Fedora QNight or a Silverblue or an OpenSUSE Kalpa or Eon or any one of those, quote unquote, save you?
No, they don't mean anything in this case. Because
and that's what I wanted to hear. That's what I wanted everybody to know, is that no, it doesn't save you.
It doesn't do anything one way or the other for you, right? Like, so all
it's
of those...
It's just a deployment methodology.
Yeah, it's just a deployment method. Like, immutability was something that was coined in when Docker started becoming popular with their container image delivery method. But immutable just means unchanging. It doesn't mean not vulnerable. Hey, you know what you can do? You can ship a wholly vulnerable, super broken image 50 bajillion times and not know how to fix it. Right? That you can do. And guess what? Because those are immutable, those fixes are not mitigatable. You can't, those vulnerabilities are not mitigatable. They just exist. You are just screwed. That is all that means. So, like, immutability is a different axis. It is a property of how the system exists. And also, it's not real in most systems, right? Like, immutability is illusory. I have a whole other spiel about this. It's not really worth getting into, but the important part is...
For a different time.
Yeah, for a different time. The important part is immutability is just not part of this conversation.
Yeah, immutability, like from a security standpoint, yes, it does. It may, in some cases, it does make patching a little easier, makes upgrades a little easier. It will never be a silver bullet, because at the end of the day, like with an immutable operating system, let's use Fedora CoreOS, Fedora IoT as an example. If I deploy an application on top of there, it's likely going to be a Podman container, or in the case of CoreOS, it could be a Kubernetes pod. Just it's the vulnerabilities are that people that are exploited are in that application space. That's generally where the exploits occur. So that's where it needs to be secure. That's where you need stuff like that provides as fast a patching as possible to get to as close to, I hate to use the term zero CVE because that's impossible, but to get as close to that as you can in that application space, especially if you're moving at breakneck speed and you're a builder of applications. I think that's very important. Also, on top of that, in this age of of Claude Mistral, or what was it called again?
Mythos, I believe.
Mythos, not Mistral's the AI company in France. Claude Mythos is the in this age where that's out, like, you got to move faster when it comes to upgrading systems, patching your applications.
I think we covered everything.
My zero CVE.
Okay, look, man. I'm just trying super hard to not go into how much I don't like the zero CVE thing. But okay, zero CVE is a phrase that should be deleted from the face of the earth. Like, all you can do at the end of the day is understand your environment and understand the risk profile you're in, and work with that.
And that's get as close to zero CV as you can.
Stop it, Brandon. Stop it.
Is it like one of those square root graphs that you see where you try to get as close to like zero or as possible?
I mean, there's a compliance oriented condition here. Like, the reason the zero CVs thing happens is because when you do audit reports, A lot of times you'll just fail if they discover a CV that exists, even if the CV is worthless, even if the CV doesn't matter, even if your risk profile says that the CV is effectively non-existent. The fact that it exists fails you in an audit. And that lack of nuance is a real pain. And man, I will get on my soapbox about this, but we don't have time and I don't want to do it. But like, man,
You've
I
taught me
really
something very
dislike that.
important, though, Neal. Before we wrap this up and say goodnight, you have taught me something mathematical.
Oh no.
Hear me out.
Okay.
CVE equals y equals the square root of x. Because you'll never really hit zero either way in that graph.
I hate you.
But I'm right.
I hate you.
It's like the stunt that I pulled on Linux Out Loud when I convinced Nathan that data has weight.
I hate you.
And on that wonderful note, it's time to say goodbye. Thanks for catching up with us, Brandon. It's always nice to have you. We've missed you, and we hope that you come back and visit us again.
I'll go back to my BSD jail.
Yeah.
Back to your BSD jail. We'll throw your SSH keys away, and maybe we'll find them somewhere along the way, or you'll discover your own version of quantum encryption, in which case those keys won't even matter, and you'll just break out of the whole jail, Kool-Aid Man style. So, as always, thank you for tuning into the SUDO Show, where business meets Linux, and we bid you goodbye and see you soon. Take care.